Today's Analog by Design show is sponsored by Tektronix. Tektronix provides next-generation test and measurement solutions that can help you solve your toughest design challenges. With over 55 years of experience, Tektronix brings you the latest advancements in probes, oscilloscopes, logic analyzers, and signal sources, as well as application-specific software from Tektronix.
From the high-performance analog IC design and manufacturing capital of the world, it's National Semiconductor's Analog by Design show. Here's your host, the guru of analog, the one and only Bob Pease.
Good afternoon. This is Analog by Design from National Semiconductor with host Bob Pease and a cast of thousands. We got a lot of people coming in here today. And our first topic, well, the first topic is hello, Paul Grohe.
Hi, Bob.
And hello, Paul Rego.
How you doing?
And do we have a guest with us today?
We sure
I bet
do.
we do.
We got one of our favorite pals, Tektronix, the stuff we love
Very
to
good.
use. And the person from Tektronix we're going to see today is Mark Albert. Mark, come on down. He's the product marketing manager for Tektronix signal source product line. He's been with the company for 8 years, and he's responsible for function and arbitrary waveform generators. He has an MSEE from the Technical University of Darmstadt, Germany, and an MBA from the University of North Carolina. Welcome, Mark.
Welcome aboard.
Thank you.
Now, it just so happens we're going to be talking about function generator stuff and good high-tech stuff. So let's see. Oh, let me just shove that off to the side. When I started in this industry only about 45 years ago,
Dinosaurs were
they
still walking
gave
around.
me this dinosaur-powered Heathkit function generator, and I said, you go out and make sine waves with that thing. Well, we did, and we could even make square waves, but we couldn't make pulse trains or couldn't make different duty cycles until we discovered there was a trim pot right back there. And rather than build a hole in this thing, we put a long shaft out through the top of the case and built a hole in it and put a knob on it. So now we had a duty cycle adjust at the top of this Heathkit sine square
Is that 20
generator.
megahertz? Or?
No, that was 2 to 20 times anything, where it would go all the way down to 20 hertz. And I think it went to 20 kilohertz. I don't think it went to 200 kilohertz.
Kind of like an
it was
audio.
just what you just minimally needed for audio.
And you're doing tube amps.
Oh, these were tubes, and we were working on tubes, and we were also working on solid-state amplifiers too. And I still like to use function generators with triangle waves. Now, what do you get from a function generator? You can get your sines, and your square waves, and your triangles. And then you can adjust the duty cycle to get different sawtooths and trapezoid and little pulse trains. And you can get noise. And you can get AM modulation and FM, frequency modulation. You can get sweeps. And you can get arbitrary functions. And in this instrument we're going to be looking at, Tektronix AFG 3252, it's a 200 megahertz function generator, and it can do all of the above.
Is it 200,
Is
Mark?
it 200?
Actually, it's up to 240.
Oh,
It's 240.
Analog PowerPoint. Check this out.
Correction.
I like blue. That's good. 240.
240 megahertz. Very good. Now, I mentioned all these things it can do. Did I leave out anything?
Oh yeah, Paul.
What?
Well, it can do all the things you listed, but there's also some other modulation standards like phase modulation or frequency shift key. And there's also another mode that many people use, burst mode. So, those are some of the things the instrument can do. And also it has dual channels, so you can actually do two different signals, one sine, one square, or ARP, can be any combination, also at different frequencies.
Well, that's a lot of capability, and every once in a while, when you really need it, that's really useful kind of functions to have. So we have all these capabilities that are pretty impressive in one little instrument. I guess we'll be looking at that more in a short time.
Mm-hmm.
Good?
Yes.
Now, what was the next topic? The next topic is, do we have any hot new analog amplifiers?
Yeah, I always like to ask Paul, because I'm over building G now, and I'm not up on all the cool parts coming out of the amplifier group.
You need to reach over and put that thing in here.
Okay.
What do you got going over there?
We got some new high-speed parts, the LMH 6702 and 6559, which actually brother and sister. Basically, one is the op-amp version of the other, one's a buffer. 6559 closed-loop buffer, basically, yeah, buffer. And an LMH 6702, which is the general-purpose op-amp version of that. That's a nice 1.7 gigahertz op-amp.
Oh, you're kidding.
So, and very, very low distortion.
You can
I
almost
noticed
make
that.
an FM radio.
At 75 megahertz, it's got minus 67 dB.
DBC.
DBC.
Oh, there it
and that
is.
means
Pull it
it's
over.
way the heck down there. Paul, you took some of these measurements?
Yes,
distortion?
that was, well, me and Joe.
Yeah.
But we,
Have you ever seen any amplifier with lower distortion than this?
no, not really. It's,
I know it blows
Okay.
away the...
Boy.
I was looking at competitive data sheets.
it's hard to make generators clean that far
Oh,
down.
yeah. It's rather hard.
Payman, the design manager, was saying you could use this as a gain block. Instead of paying thousands of dollars for a gain block in a Tesla where you have to buffer a signal to drive 50 ohms, you could use one of these parts, and your distortion will be instrument like Tektronix quality distortion numbers. So this is a pretty exciting part.
Very good. Okay. Any other technical stuff we want to look at in here? Mostly it was just this page. And you can look these things up on the web and print them out yourself and have fun with them.
Right, this is just
But
the data
I
sheet.
like that
We
low
checked.
distortion.
Yes.
Yeah, it's awesome. And then there's another part, this video part we're going to look at. We have a little demo after we look at some arbitrary waveform stuff. We're going to do a demo of this.
We're going to show you how to turn your old computer monitor into being able to watch DVDs
Oh, cool.
without a computer.
HD TV into a computer monitor.
A
And
standard computer monitor.
Are we going to look at that now or later?
We'll watch that. We'll see that after.
We'll see that after. Okay,
Tektronix.
fine. Okay, now, are we ready to go to the lab?
yeah,
What
I
are we
think
ready
so.
for?
Mark, you want to show us some of this
Yeah,
good stuff?
sure.
Very good.
Okay,
Lead
we're
the
gonna,
way, please.
well, we're going to bring in Claude Turner, who works on a lot of video products, and so Claude's going to meet us over there, and then later Cliff is going to show up, and he helped define this
Like I
video
said,
part.
a cast of
Cast
thousands.
of thousands today.
Oh,
This
man.
is-
Let's go meet him.
Okay, let's go over there and bring in Claude.
Hi, we're over in the lab segment now. We've got the cleanest bench we've ever seen for a real engineer, but we wanted it pretty for all you people who appreciate it. Claude Turner's here. Claude's an assistant engineer in our amplifier group. He's worked with CRTs and video signals, and he got real excited about this equipment because it can do tests that competitive machines can't. It's fast enough to do that. And of course, Mark's here. Mark Albert's still here. Mark, can you show us a little bit? We're going to have Claude show us what he used it for. But if you could just give us the basics on why this is a cool piece of equipment.
Sure, yeah. Let's take a closer look here at this instrument that we have here. You see the model number here is the AFG 3252. That is actually a member of a complete product series, and this happens to be the top end of the range. That is, as Bob already explained before, a function generator, a pulse generator, and also an arbitrary waveform generator, all in one. This instrument has the capability of generating sine waves up to 240 megahertz, arbitrary and pulse waveforms up to 120 megahertz, and it does that with a sampling rate of 2 gigasamples per second. Now that's pretty powerful for such a small instrument, and what enables this instrument for this top performance is a new technology that Tektronix invented and put in here, and we call that a generator on a chip, GOC. And there's one single integrated circuit here, a custom IC, that incorporates the direct digital synthesis waveform generation, the waveform memory, the digital to analog conversion, and the modulator. And that is all contained in a single chip, and that makes all this performance available in a compact form factor and at an affordable price, well below $10,000.
The user might not be able to see. This is a lunchbox size. It's like the real, so it's only that deep. So it'll fit on your bench and give you plenty of room to have your other test equipment and your test device under test.
Right, exactly, yeah. And we got all the standard functions on here, sine, square, ramp, pulse. You can select it all with a button push. And what's unique about this instrument is that it has a large screen that shows all relevant instrument settings at a single glance. If I may point out some of those here, for instance, we see the frequency, we see the phase, we see the amplitude, and the offset here. and we also see a graphical representation of the waveform. So the user gets full confidence in the instrument setting. By just looking at the screen, he can already see what's coming out of the instrument output. Now, the instrument has also modulation capabilities. For instance, amplitude modulation that we see here. And now we see on the screen also the modulating source, the modulating frequency, the wave shape, and the modulation depth. So there's a lot of information that you can see at a single glance. Now, going on through those functions, let's take a look at the pulse functions, for example, here. The pulse waveform, that has independently variable leading and trailing edges. We simply select that here by pressing the shortcut key, and then as we change the parameter, the image on the screen changes. And if you look at the output with an oscilloscope, you see the same
Yeah, down below we have a scope.
Right, you see.
That's my favorite thing about this. You're not guessing,
right.
and you're not tying up scope channels. You can trust what's coming out of it because it gives you a picture.
Exactly.
That was just a pleasure. We should mention too, it's 2 channels, right? It's available as a 2-channel box if you want it.
Right.
So if you want to do differential things, my laser driver stuff with differential inputs where you're trying to get rise times, this would be great for that.
Right.
And it's fast enough,
Exactly.
which is rare.
Yeah. And with those 2 channels, you can either generate completely different waveforms at different frequencies, or you can do something like synchronously with the same frequency and a phase shift in between channel 1 and 2. All that is possible. And I didn't mention yet, we do have the arbitrary waveform capability, and what it's unique about this box is you can actually read arbitrary waveforms from a USB memory device. You simply insert that memory here, just like
right
you
on
do.
The front.
Yeah, just
That's
like
great.
you do on a computer, and then you can import waveforms here. Just to select the memory, you select the directory you want to choose, and
all those waveforms are on the stick you just plugged in.
right. The screen gives a list of what's stored on the stick here.
Oh, that's cool.
Right, and then you just select whatever you want to load, and the instrument loads it. Here we're looking at an I2C data signal, so you can actually simulate low-speed serial data streams.
Yeah, complex bus things. Now, how do you come up with the arbitrary waveforms to put on the USB stick?
Yeah, that's a good question. Well, you can do it on the instrument, but more conveniently, you can do it with a piece of software that's included with this box. It's called ArbExpress. It's a PC software.
But it comes with the box.
It comes with the box.
I thought you had to pay extra for it because it did so many things.
Nope, it's all included, and it allows you to generate, to create waveforms from standard functions, sine, square, and you can do a freehand edit, add anomalies or distortions to it. You can also import waveforms from any of the Tektronix oscilloscopes, directly acquire the signal you want to simulate here. You load it into the software, maybe modify it, and then write it onto USB memory, and then off you go.
Oh, that's great.
Yeah.
That's one thing that's good to do is it's really easy to create good waveforms for your circuits, but it's another thing to throw some little unexpected problems into those waveforms and see how your circuits react to it. Put little glitches in your sine wave, put a little extra glitch in here and see how your circuit...
Right, that's what Claude told me. He said there's all kinds of standard video signal generators that make a perfect within spec generator, but what this will do, let you capture it or come up with your own and start moving the pulses. And he was playing around quite a bit with that and had some good results.
Yeah, purposely distorting your signals.
Yeah.
Yeah.
And then there are also a number of other capabilities. We don't have time to talk about all of them, but just to give maybe one more example, if we have any type of signal, and let's say we want to add some noise to it for like limit testing or just see how the device responds if the signal has a little bit of noise.
I do filter stuff. We've got our WebBench filter designer, and it's real curious as well. The filter's supposed to take noise out, and so if you could generate the noise, that'll tell you and make an easy, trivial test setup.
Right, and we actually do have a noise generator integrated for each of the channels, so it's built in, and you simply select that noise function here, you turn it on, and then you add a noise level to it.
So,
and you see how the signal gets
on the bottom
noisy
on the scope.
here.
Yeah, that's great. And you could do it to any, that would apply to both an arbitrary signal that you created or any of the canned signals, square, sine,
exactly.
triangle.
So if we hit sine, we can
You
actually
got
make a
fuzzy
noisy.
sign.
Oops.
Yeah, we'll have to quickly go back to that menu. All right.
Okay, and we can.
Oh, look at that. And just dial in how much noise you want.
Exactly.
That's beautiful. Okay, that's great. Anything else you wanted to mention?
The instrument also has standard communication interfaces on the rear.
GPIB.
LAN, GPIB, right.
That's
also
great.
USB.
Oh, really? So you can talk to this USB?
Yep.
Oh, that's great.
And by the network. So this is a 14-bit.
It has 14-bit vertical resolution, right.
14-bit.
So it's making pretty pure sine waves if you've got that many bits to make your.
Yep.
So you get good spectral purity
Very clean
for that.
signals. Very high frequency resolution.
Oh, that's great. Well, this is a good thing. This is what Claude got excited. Claude, you mentioned, hey, I've got a test that my present equipment, competitive equipment, won't do. What was that you used this for and set up a test for?
An engineer came to me and said he wanted a test to evaluate the overload recovery on an amplifier that he was looking at. And what he really wanted was a 1 megahertz signal that went from 1 volt peak to peak to 50 millivolts peak to peak. And he didn't want any artifacts on the change. And I couldn't do that with any of the generators that I had before, because the only way I could try and do it was with amplitude modulation, and none of them were fast enough to shut the signal off. With this, I generated a waveform mathematically.
We'll get you back. It's the first one that we loaded in.
Just a second.
Look how easy this is. This is spoils us. Look how easy this is.
This is a waveform that I generated mathematically. Whereas it's got 5 pulses at 1 volt peak to peak and then 5 pulses at 50 millivolts peak to peak. And you'll notice that there's no strange artifacts at the,
there's no overshoot.
change.
And that's really being measured. That's from the scope.
And that's the last thing you want is some interesting artifact, which you'd get from amplitude modulation here, because you want to see what the amplifier's doing and not what the generator's doing. And this worked out quite well for that.
Well, thanks, Claude. That was great. Now we want to bring on another amplifier guy, Cliff Wynn. Cliff, come on in here, and you can change places with Mark. How you doing? Cliff worked on this new part. It's an LMH 1251. What can you tell us about the part?
Well, just wanted to show you the data sheet. This is LMH 1251. And what it is it's a high-speed 2-to-1 video mux integrated with a color dematrixer integrated with a sync processor. So going through the switching, you can either have channel 1 or channel 2 video. And channel 1 video is driven by PC video from your computer or your laptop, or in this case, we have it driven by the Tektronix scope. Channel 2 is driven by an analog component video path, which is either your DVD player, your high definition tuner, your set-top box, your VCR, anything like that.
I want to point out what's on the screen from the scope. It's hopping around a little. Remember when we added noise to the waveform? The generator isn't noisy. We added noise.
We forgot to turn it off.
Yeah, we didn't turn it off. We're sorry about that.
Yeah.
So right now you can switch now with a little jumper, right?
Right.
Between
so
the two?
right now it's the Tektronix scope is driving the video. If I switch over to channel 2,
we're going to go to a DVD player, that silver box up by Mr. Grohe, which is running.
So now I have a DVD player. And so when I select this path, what happens is it takes the YPBPR video, strips the syncs off into horizontal and vertical sync, and then it does the color space dematrixing. So it goes through some linear algebra math and converts from the YPBPR color space to the RGB color space. So now basically you can turn in your old CRT monitor into a HD TV.
Oh, that's great. It looks great. They're not going to see it on the web, but the quality of that image is beautiful. You did a great job on this part.
Yep. Thank you.
Well, but that's good because it's analog. That's not
Oh,
digital.
that's right. There's
It's
no
all
digital.
analog.
Bob's got to get that in. Everything
Well,
is done analog.
Done right.
It's analog and it's real precise. It's within 2.5% of color accuracy and within about a 1 degree of phase accuracy. So it's a real precise analog color conversion. So if you come from your, let's say your DVD player all the way through here, this is a full analog path right to the yoke of the CRT. Or you can run it to LCD monitor too.
Right.
Either way, it's a full analog path, because you would think, well, what if I put my DVD in my computer and play it? Well, that goes through a bunch of upscaling and downscaling and goes through a bunch of digital paths.
So that's nice. I know people like CRTs because the color accuracy is better. If you're doing pre-press and things like that, they like CRTs. And then the gamers like CRTs because the motion is better.
Precisely. Oh, you can actually run your Xbox too.
Oh, really?
Xbox, your PS2, PS3, Xbox 360 can go through this, and now you can play it on your computer monitor.
Yeah, anything that has a standard
Analog YPVPR. Yeah.
And that board is our board. It's our eval board.
Yes, it is. You can order it on the internet.
I looked it up. It's about $150. So all my hacker friends are immediately on the web. Hopefully they won't run us out. But we showed this at NAB. Everybody went wild over it. So it's a really cool video. LMH is it in VIP 10? Is it in that
CMOS
process?
7.
It's CMOS 7. Okay.
Okay.
Yeah, the great thing about this is you can take your old CRT monitors and rejuvenate them to now be part of a kind of a little mini home theater. Since you've got that new flat panel, but you have that great old CRT monitor you bought years ago, it still works. Why not give it new life as a really good video display?
And you need your CRT to keep your cat warm.
Yes.
Because he's getting really upset with that LCD.
Yeah.
Bob, anything else you want to chip in with?
I think we covered all the points. I think we gave a good demonstration of several different machines. I think you've had a lot of fun along with us. I've had a lot of fun, learned a lot about some of these ICs. So thanks very much. Hope you had a good time too. Bye-bye.
Bye now.